So here we have our notes from last time. We were talking about the real number system, and we started to define some of the real numbers that we know. So if we look in here, we defined natural numbers, right? Whole numbers and integers. So the numbers that we still have to define are rational numbers and irrational numbers. So we're going to go ahead and do that today. If you notice, I'm running out of space on my first page, so on the second page, I just added a line so I can keep writing. Okay, I added my left column line. So the first number we're going to talk about are rational numbers. Okay, and if you notice, the word ratio is inside the word rational. And ratios basically mean fractions, okay? So we have to keep that in mind when we're talking about rational numbers, okay? So let's define this right now. Rational numbers are numbers where any integers can be written as a ratio. Okay? And another way to say ratio is fraction. So that's why they're called rational. They're any integers that can be also written as a ratio. So let's see what I'm talking about here. Okay? I can take the integer -3 and turn it into a fraction over the integer 5. That's a rational number because I created a ratio. Okay? I can also do the number 7 over the number 1. That is also a ratio. And that ratio is actually the same thing as just saying 7. So if you notice, that's also a rational number. I can have a fraction kind of like the number, 2/3. Okay? So excuse the sound in the back. Sorry, guys. So I can have that fraction. And then I can also even write my ratios in a different way. What if I wrote 0.5? Isn't that just writing the same thing as 1/2, right? So I can actually have decimals in my rational numbers as well. So let's kind of talk about the kinds of decimals I can have. Okay? So there's two types of decimals that we can include here. So the first kind is called a terminating decimal. Okay, so these are decimals that stop. So terminating, if you don't know what that means stop, something that stops. Okay, so a terminating decimal example could be something like 1.4, see? It just stops, 0.4 and stops. It doesn't keep going. Or 0.25, see, it just stops. Or even something like 6.148, right? It's a longer decimal, but it still stops. So terminating decimals are one kind of rational number. The other kind is called repeating decimals, okay? Repeating decimals. And they're numbers that go on forever. So what a repeating decimal is it goes on forever with a pattern. Goes on forever with a pattern. So what do I mean by that? So I actually want to show you something. I'm going to go to my calculator real quick, okay? And for example, we know that 1/3 is a ratio, right? So 1 divided by 3, 1/3. If you see what it looks like when I hit equal, you see how it's this decimal? It goes on forever. It's 0.33333333333 forever. Sorry about that ad. So that means when we go back to ratios and we do some examples, 0.333 going on forever is a rational number because we know that this is really the same as 1/3. Okay? So another example of that would be like 0.54 going on forever. And this bar means that it's repeating with a pattern. Okay? So that, oops, sorry. It means it's repeating with a pattern. Anytime you see a bar like that, it's going to be a rational number. Another example could be, I don't know, 0.77 with a bar, which means it goes on forever. Okay? So those are our rational numbers. Then we have our last category, which is irrational. Irrational. Okay? So let me go back to my old notes. Remember when we were doing real numbers? All of these right here, they're all rational numbers. They're just different kinds. The opposite of that is irrational. So that's what we are going to define now. So if I define irrational, going back to my notes, irrational numbers cannot, so it's literally the opposite definition, cannot be written as a ratio. That's it. That's the basic definition. So they can never be written as a ratio. So basically, all irrational numbers are, actually, sorry, I didn't mean to write that. All irrational numbers are decimals that go on forever with no pattern. They go on forever with no pattern. So an example of that would be pi. Pi is a number, it's a decimal that goes on forever and there's no pattern. 3.1415926 ... goes on forever. Okay? Another example is the square root of 2. If you put that in a calculator, and I can't put it in my iPad calculator, but if you put that in a calculator, it's this crazy decimal that goes on forever, has no pattern. We can even come up with one ourselves. Let's do like 1.761425 ... goes on forever, and there's no pattern. Okay? So now we have all of our definitions, and you've heard me talk for long enough, so I'm going to stop the video and let you guys do your next activity.